get started. Today is very open-ended, so ask what you want. If I answer it and you're happy, then bye-bye, get on with your studying. If you want to stay to the end or till everybody's finished, whatever that is, that's good as well. So, who's got your first question? Okay, while you're thinking about it, let me show you something that is new. Let's go into student view. Can I do that from here? Yes. If you go to student view, you'll now see the final exam module. And on that, you click on this. Here is the special Zoom link. When you do your final exam, you use that Zoom link, not your class Zoom link, that one. So there it is now. That one better be blank, and if it's not good, it is. There's how to upload Microsoft Lens for those who need reminding. There's no need for you to have Desmos, that's something from somewhere else. That guy there is upload your working. And just to remind you, you only get working for part 2 of the exam, right? The bit that's on Canvas. But you would hit the start, submit assignment. Try that again. Hit submit assignment. You must be at least, what? Oh, upload file. Choose file. Out of sync here. Find whatever your file is and hit that guy and then submit assignment. And I think I've chosen one of the PDFs in my textbook, so that'll take a while to load. But that's essentially what you do. And you're finished. So close it off. Oh, sugar and spice. Go away. Leave student view. Right. Okay, go home. And try leaving student view. It's just been a pain right now. There we go. And there you are. All your good stuff. Final exam module. So, any questions? None? Okay. Well, maybe if I go down to syllabus and we go to our list. Chapter 1, getting started. Right, remember doing those guys? Frequency tables, pie charts and stem and leaf, mean, mode and median, standard deviation, 5-figure summary, probability, probability with probability trees, normal distribution, then sampling, finding 90, 95, 99% confidence intervals, hypothesis tests, and regression. And that's it. Anything on that list you want to go over? I mean, I can pick stuff, but picking stuff doesn't necessarily be what you want, but I can do it. Okay, I'll do it to start with, and maybe that'll lead to something. Right, let's suppose we want to do a hypothesis test question. Now, a hypothesis test question will be the web assignment. And you know that you're going to, if you get those questions, and you will, that you're going to have to use SALT. So that's where it's going to be. So let's suppose that we have a single population. Right? And we want to see, let's see, what should we do? And we'd like to find out, is there evidence that the proportion of people who drink beer has declined. So in America, the Budweiser companies and people like that are thinking, you know, there's less people drinking beer than there was 10 years ago. So there will be a kind of null hypothesis, which is what was it true in the past? So let's assume that in the past, the proportion of people, adults who drank beer on a regular basis was 30%, right? It was 0.3. That was in the past. And we are going to see if there's enough evidence then to prove that it has declined. So you collect a sample, and in this sample, p hat, you got 45 people out of, what would that be, 180. And I'll turn that into a decimal. So 45 people divided by 1 to 80 is 0.25. And we are going to use a significance level of 0.01. So that's pretty much everything that you need to answer this question, isn't it? Right? You've got that fella, you've got this guy, the sample, which is clearly an indication that it might be true, and we are going to prove that it is. So we'll set up our null and our alternate hypothesis. Since this is a single proportion question, the null hypothesis is just going to be p is 0.3, and the alternate is that it's going to be less than 0.3. Are you comfortable with that? Right. So if you bear with me for a few seconds, I'm going to go into WebAssign now and sign in and do our thing. And pick somebody that's got a salt button. Doesn't really matter what salt button it is. So I'll do that one. Okay, I'm ready to get started. So you would click on the salt button, and let's say this one, just so I've got one to play with. And go to inferential statistics, and over here, and you have a decision to make. For a one sample proportion, which this story is, a hypothesis test, you would be looking here, right? And one sample proportion. And in this case, we are going to be doing a hypothesis test. The number of successes were the 45 people out of the 180 in the sample. We're going to compare it against 0.3, and we're trying to say its alternate is there evidence that it's less than? Are you comfortable about that's the heading, that's the successes, that's the trials? For a single proportion, it used to be 0.3. Can we prove it's now less than? Now I'll generate results, and there's our null alternate. And if they ask you for the test statistics, isn't it that number, right? They call that the test statistic. The guy we're really interested in here, isn't it that guy there, the p-value? So in this case, the p-value is 0.07 and some other decimals. And now I'll return back to my notes. Now, the way WebAssign does that, don't you get like 4 or 5 choices? And one of them will look probably something like this. And that's the one that you will pick, because when you have this guy, isn't A between 0.05 and 0.10? So that's how you choose your p-value, right? Now, conclusion time. Is the p-value less than the significance level alpha? Is the p-value, which is that number, less than this number? And would you agree that the answer is no, it's not? And when it's not, don't you have that sentence that goes something like, for a significance level alpha of 0.01, there is not enough evidence to reject the null hypothesis, and so that this is statistically not significant. Now, suppose the question was exactly the same with one alteration. Suppose the significance level was 0.1. Then when you do the is the p-value less than alpha, you will be doing is 0.07 less than 0.1, only this time it would be yes. And when it's yes, you will then choose from the list of 4 the sentence that looks like, for a significance level of alpha equal to 0.1, there is enough evidence to reject the null hypothesis, and so it's statistically significant. And in English, you would say, we have proved that the proportion of people who drink beer regularly has declined, right? Has got smaller. And that would be a classic WebAssign question using SOLE. Yeah. Some technical stuff here, but just to tell you, when you get to do your final, it's set up just like it is normally, right? There'll be a WebAssign button to the guy that you need, and that's okay. But for security purposes, everybody will get a different question, to which you'll say, but that's what we always get. Well, not really. Don't you get the same question, but with different numbers? What you will get in your final is a different question. And what I do is I just take a whole bunch of questions and I pull them. So Mackenzie gets version number C and Zach gets story number D. So even if you did want to contact each other, Zach would be saying, I'm doing a question here about politicians and do they win the election? And Mackenzie's going to say, well, my question is about drinking beer. So you wouldn't even be able to help each other, right? So not that you would want to, but I'm just putting that down there as one of the ways in which we make it fair that everyone's getting tested the same. Obviously, I get to see you. Have I mentioned, I think I did, that there is a new Zoom link for the final, and it's in Canvas. So make sure you use that one and not your class one, or else we'll get all confused. Okay, that questions just to get the ball rolling, get your thought processes. Any questions? I mean, you don't need to be here. I'm not trying to get rid of you either, but you know.
Maybe we go over, like, review a little bit of the mean, mode, and median.
Sure. The mean, mode, and median questions really will happen in Canvas, because you can do working for these, or at least partial working. Most of it's going to be done by your calculator, right? But you could get it that way. It also allows me more flexibility in the questions I can ask. So mean, mode, and median. So you won't get huge data sets. 1, 2, 3, 4, 5, 6. There's a data set, 6 numbers. If I asked you, as I might, to get the mean, the mode, and the median, okay. Your calculator would be the simplest way to do that. Now, for a small set of numbers, you could actually just do it almost by hand, but, you know, and that's fine if you want to. But just to remind you how you would do it, you know, if the data set was a little bit on the big side, I'll start from scratch. You hit the start button. You go into number 1, edit, and if there's data from previous questions, just hit delete button till they all go. And then just type in your numbers, 1, 3, 4, 5, 17, and 21. That was easy. Then hit the start button again. Hit this button over to calc, and one variable starts is pretty much the go-to guy. So I'll hit that. In my case, I have to tell it the data is in L1, so blue button 1. In some of your newer calculators, there's a slightly different way of doing that. And here is a lot of information. X bar is the mean, so that would be 8.5. The median, you have to scroll a little bit lower, and it's 4.5. I got the, put it there, 4.5. The calculator will never tell you the mode. Isn't the mode the most popular answer? Now, in this case, would you agree that there is no mode? Right. They're only one of each number. But for argument's sake, can you pretend that there was 3 5s? Right? Pretend there was 3 5s. If there was, the mode would be 5, right? And that's mean, mode, and median. Now, you can see in that question, there's really not a lot of working you can show me because it's done by calculator. And that's fine. You know, not all questions involve you showing the working. But let me take this one a little bit further. I'm also going to get the 5-figure summary, and I'm also going to get the standard deviation. Now, the standard deviation in this is called SX, and it's roughly, what, 8.3 and change. So I'm just going to call it 8.3. Now, why am I doing that? Well, maybe you could get a question that asks the following. Is 21 an outlier? Now, looking at that list of numbers, I'm not really, I don't think it will be, but we can't just say, I don't think it will be. We have to kind of prove it. And so if you want to use the standard deviation as your test for an outlier, you take the mean and you add and you subtract. Can you remember how many standard deviations you use to decide where the outliers live?
Is it the one where they have the percentages of like the 98.5%, the 13? Is it?
It's connected to that.
Okay.
How many standard deviations do you use then for an outlier? Almost 3. Right? So 3 standard deviations away. That's the 99.7 in the empirical rule. Right? So 3 standard deviations away. So in this case, I have a mean of 8.5, and I can add and subtract 3 lots of 4.5. Now, since I'm interested in, is this an outlier? I only need to do the upper range, which is 3 times that, which is what, 12. It's not 12, 13.5. And that gets you 22. So isn't 21 inside the safe side, right? So now you can say something like, since 21 is less than 22, it's not an outlier. Which we pretty much suspected it wasn't going to be anyway, right? Now, since I've got this data, I'm going to now use the same set of data.
I'm confused on where we got the 8 minus 3, like the standard deviation, and where we got the 3 from when
The 3
the test
is
for the
fixed,
outlier.
right? So the test for an outlier is always going to be the mean plus or minus 3 standard deviations. That is the formula. That is how you decide if something's an outlier. So that 3 is always there. Now, if your question is, where did the mean came from? I got that from, the mean of this data. Where did the standard deviation come from? This guy here. I got that from the calculator. And by the way, I'm just noticing, aren't my decimal points looking awfully like other things? But it is 8.3. Looks more like 8 times 3. But I've told you about my problem of decimal points look different in Britain than they do in America. So your answer to your question is, where did that 3 come from? It's because it's part of the formula, right? It's a thing you memorize, right? So it's 3 of these guys. In this case, then it's not an outlier. So if you take this fella, you could be asked to find a 5-figure summary. And they're these guys. Now, all of that is also in here. So you just need to look at where it is. So the minimum is 1. Well, it's pretty obvious. Q1 is 3. The median we already got is 4.5. This guy is 17 and the maximum is 21. So if I asked you for a 5-figure summary, wouldn't that simply be just to do it in your calculator and get it? But it still would be in Canvas, right? You wouldn't be using WebAssign to do that. Now, what else could I ask you? Well, I could ask you to draw a box plot. Now, when you do a box plot, you go 0, 1, 2, 3, 4, 5. So make that 10, 1, 2, do that 20, there's 2, there's 4. You make a scale, whatever scale is big enough to fit the largest number, and maybe a couple more. You then take the smallest number 1, which is here, do a little mark. Q3, Q1 I should say is 3, so it's about here. Then 4.5, that's a little bit like here. 17, which is about here. And finishing with 21, which is here. So the Q1, 2, and 3 use big lines, and the minimum and the maximum use little lines. And that's how you would do a box plot. And be careful that you have a scale here. Don't just go 1, 3, 4.5, 17, and 21 and just draw a box with the numbers there. If there's no scale there, it's not really drawn the way it needs to be. Right, I'm looking at a box plot. Skewed left, skewed right, or symmetric? Which one of those 3 is the most likely based on this picture?
Skewed right.
Okay, would you agree? Would you agree this tail is? Okay, might disappear. At least it tells me. Can you still hear me, guys?
Yeah.
We can hear you, but you sound like you're underwater again.
Okay, you hear me now?
Yeah.
Is that clearer? Yeah, I know why it does that. It's a pain in the butt. It's probably something to do with my computer. Right,
Because you're
so
using Sprint.
what were you saying, Aidan?
You're using Sprint. Can you hear me now? No.
Oh, the Sprint. Yes, you're right. I was. Right. So this is bigger than that, and this is a little bit bigger, big enough to be important. Big guys on the right, Mackenzie. Scoot on the right, just like you said. Now, let's suppose I asked you the same question. Is this number an outlier? Now, when we did this test using standard deviation to decide if you're an outlier or not, the formula was the mean plus or minus 3 standard deviations. If you're outside of this range, in other words, if you're bigger than this number, or on the other side, if you're smaller than the mean, take away 3. If you're outside that, then you're an outlier. There is a different test when you use the 5-figure summary. So here is the test for an outlier using the 5-figure summary. We have two guys called the lower fence, and the other one is called the upper fence. And each one of them has a slightly different formula. The lower fence is Q1 take away 1.5, something called the interquartile range. And the upper fence is called Q3, and it's add 1.5 interquartile range. So here's the puzzle for you. Does anyone remember how you find the interquartile range?
You subtract Q1 from Q3,
Okay,
right?
correct. In this case, 17 take away 3, so the answer is 14. Now, since I'm only asking is 21 an outlier, I only really need to find out what this number is. Now, if 21 is bigger than the upper fence, it's an outlier. So let's see what that is. Q3 is 17, and if you add 1.5 interquartile ranges, which is that guy, you get 21, 38, you get 38. Would you agree that 21 is safely inside this? So it's not an outlier. So you would say something like, since 21 is less than 38, it is not an outlier. So if this was your question, I wouldn't see any working for this, right? Wouldn't that come straight out your calculator unless you wanted to do it by hand? I would see a little bit of working, right? You'd have to show me where the interquartile range came from, right? You had to do something to find it. And if this was part of your question, wouldn't that just be drawing the diagram? There's no working you could show someone. And if I was asking you then, is this an outlier? Wouldn't you be just showing me this bottom piece of the working, finishing with that sentence? So if you're thinking, what do I need to show and what do I not need to show? You don't need to show the calculator stuff. You don't need to show drawing the picture stuff. There's nothing really to show here, right? And you do need to show the upper fence calculation and the interquartile range calculation. And you also need to tell me why you said it's not an outlier, right? You couldn't just do this and then say, it's not an outlier. Because I would say, why do you know it's not an outlier? Oh, because it's less than this guy. So you have to tell me that's why you decided, right? Are we good? Have we got another topic?
Yeah, could we go over measures of variation, in particular Chebyshev and coefficients of variation?
Can't even spell the guy. Chev. I hope I haven't annoyed anyone with Russian ancestry. Chebyshev. And the other one you wanted is the coefficient of variation. Is that the one you're talking about?
Yeah, there's a question from one of the
Mhm.
homeworks that
That would be
kind of
perfect.
goes
Do
over
you have,
both of them.
right, could you tell me which homework it's in? That'll make it easier if I choose
Yeah, it's
a
in
number.
chapter 3, measures of variation, number 7.
Okay, chapter 3, measures of variation, and question 7. So it's the second last question. Okay. Give me a second. Question, oh, I'm at 5. That's why it doesn't make sense. Scrolling down. So, let's do CV, which is just short for the coefficient of variation. You get this guy by using this formula. The coefficient of variation is the standard deviation divided by the mean times 100, because we typically want the answer to be a percent. So that times 100 is just what makes it a percentage. So if you have a question and you know that the mean of your data was, say, 15, and that the standard deviation of your data was, say, 3, then the coefficient of variation would be that guy divided by him times 100, which would get you percent. So it would be 3, let's get this right way around, would be 15 divided by 3 times 100%. And sorry about that. It's 3 divided by 15 over 100, which is, well, 20%. That makes much more sense. Right, so anytime you're asked for the coefficient of variation, you basically want to use that formula, plug in the standard deviation, divide it by the mean, and times 100. So it's a bit like a plug and chug question. Okay. Now, if you were being asked to do the Chebyshev one, right? So I'm reading this from here. And it's, well, let me write down what the sentence says before we talk the formula. And Chebyshev says for any value of k, positive number, greater than 1. The proportion of data within k, that number, standard deviations of the mean is 1 take away 1 over k squared. So that's the Russian guy, right? That's Chebyshev theorem. Yeah, and let me spell the poor guy correctly. There's a Y in the middle. So let's use this story. Suppose I know that the mean is 15, and I would like to know what proportion of the data, right, is within 2.5 standard deviations, then 1 take away 1 over that guy's k is 2.5 squared. And on my calculator, 1 take away 1 divided by 2.5 squared ends up being 0.84. So you could say that 84% of the data is within 2 standard deviations of the mean. Now, if I told you that the mean was 3, or the standard deviation was 3, you could use that and say the following: that 84% of the data, right, is within the mean plus or minus 2.5 standard deviations. So the mean was 15, 2.5 threes. The mean would be 15, add or subtract 7.5. That would give me a lower limit of 7.5 and an upper limit of 22.5. So I could say that 84% of all the data is within the range 7.5 to 22.5. Is that the kind of thing you wanted to know about, Rose?
Yeah, thank you.
Right. So they're essentially formulas that you plug and chug into, right? So the coefficient of variation, you plug and chug that formula, and in the Chebyshev, that number there will tell you the percentage of the data that's within k standard deviations of the mean. So that bit there tells you the 84%. And if you want to know what that interval is, you have to do this formula here, where I guess that number is whatever k happens to be. Can you remember the 1 standard deviation, the 2 standard deviation, 3 standard deviation guy? 68, 95, and 99.7. Remember those 3 guys? It's called the empirical rule. Do you know the empirical rule is just a variation of Chebyshev's? You just make, k, 2 and 3 standard deviations. So they're very closely connected, right? So if you wondered where, why is it 95, for instance, right? Chebyshev did a much general version of that, and we adapted it to make up the empirical rule. Okay, what's next?
We take a look at confidence intervals again.
Sure. So let's suppose that we want to make a 95% confidence interval, and let's do my story. I collected 200 people, and I found out that their average age was 31. And I'd like to know a 95% confidence interval for what the population is. So let's just say that this was students at some college. And we got random sample of 200 students, and we found out that their age was 31. And we would like to use this information to estimate what the average age of all the students that could go to that college. Now, that seems to me a bit in the big side, but some colleges are actually only postdoctorate, right? So you don't even get into them until you're well into your 20s, right? I can imagine some doctor, hospital type medical colleges being quite old in a lot of cases, right? So The formula for calculating a 95% confidence interval, if you were doing it by hand, would be the mean plus or minus 1.96 times the standard error of x bar. Oh, and by the way, you need to know what the standard deviation is. Let's say it's 5 years. And to calculate the standard error of x bar, you would take the standard deviation and divide it by the square root of n. So you take 5 and divide it by the square root of 200, and off you go and do your stuff. So if you were going to do it by hand, and we did show you how to do those by hand, that's how it would work. So let's show you now, because this question is essentially using salt, how you could do a lot of that heavy lifting by using the salt button instead. So with a bit of luck, we're in here. Okay. Now I just hit a salt button. It's going to have a whole load of data there that I don't care about because I'm just using this to get into salt. And if I do, for instance, well, once it's finished doing its thing, if I hit inferential statistics for a minute, and we go over here, we have a decision to make. We're either going to do a one sample t, or we're going to do a normal distribution. Now, if we do a one sample t, that's the guy I'm going to use. If I'm going to do a normal distribution, right, I'm going to go to this menu and pick the normal, right? Now, actually, now I've done that, I could have actually picked the t here, so that's probably a better place, right? So here's the question. We have 200 people. Would you agree that's a big sample? 30 or more is considered big, right? There was no indication in this story what the sigma was equal to, right? They didn't tell me what the standard deviation for the population is. The only thing they told me was the standard deviation of the sample. Because of that, I am going to be using the t distribution. And where am I going with this? Oh, then back to this fella, because he's easier. Inferential statistics, one sample t. Make that go away. Oh, shoot, you can't use it. In a normal test question, you would, because when I hit the button, the data would be uploaded, right? Unfortunately, I can't do it that way, so let's see what I can do. No, I can't do it that way either. Try to find a way around this issue of not being able to do it. Oh, I guess I could do it this way. It's a bit back to front. This is not how you would normally do it. Normally, you would just hit the button and you'd get the answer. I know a better way of doing that. Let's actually do a question where the data is there and we can just solve. That's the best way of doing it. Just picking a salt button and trying to put it in was not a good idea. Okay, so I'm going to use this guy here. So my question is going to have to change now to use one of these. Okay. Give me a salt button. Is there any salt buttons here? There we are. Okay. Phew. Okay. Back to a different story then, right? Here is your data. Can you imagine that was the 200 people and whatever their ages are, right? If you want to do a confidence interval, you hit use salt. And salt will upload all the numbers that you need. Done. If I then go to inferential statistics and I do it as a one sample t, do you see all the numbers I need are already uploaded? That was my problem before. Now, I want to do a confidence interval and I want to do a 95. Perfect. So one sample t, use the variable heading. That is here and basically generate results. So the standard deviation and all the other stuff is here, but the only two guys we're really interested in is lower limit and upper limit. So that would be the interval, the 95% confidence interval would be from this number, 1245 roughly, up to 1305. Now, let's see if I can cheat now that I've got this one. In my story, the sample mean was 31. The standard deviation was 5. And the sample size was 200. There we go. So now I can actually put my story in. Remember the one about the students and the 200 of them? Average age was 31, standard deviation is 5. Let's generate the results. And the lower limit is 30.3. And the upper limit is 31.7. And that is a 95% confidence interval. Now, it won't be as ugly as I made it out to be, because in a salt question, isn't the salt button there and it loads up the numbers and you don't need to do anything. And it's just because I made this one up, I didn't have a, salt needs a question, to work with. But that would be our 95% confidence interval. Now you can ask questions from that interval. Would you agree that there's evidence that the average age of all the people at this college is less than 32? And the reason for that is, isn't everybody in that interval smaller than 32? Couldn't we say there's also evidence that the average age is greater than 30? Okay. Suppose I got a 95% confidence interval, and I did it for a single proportion. And that single proportion was the people who were going to vote for a candidate, right? And my 95% confidence interval ended up being this guy here. If that was my 95% confidence interval, and this was the proportion of people who are going to vote for your candidate, would you agree that this is strong evidence your candidate's going to win the election? Because even in a bad day, he's going to get 51. Now, it could be in a different world. Wouldn't that be evidence he's going to lose, the other guy's going to win? We'll assume it's a two-candidate race. And if you did the 95% confidence interval, and you got that interval, wouldn't that be inconclusive? Right? Couldn't he win? Couldn't he lose? Can't really tell. This interval, everybody's less than half, he's going to lose. This interval, everybody's bigger than half, he's going to win. Now, if you do a confidence interval for the difference between two proportions, let's see how you might interpret them. If the difference between the proportion of 1 and the proportion of 2 is all positive numbers, then isn't that evidence that P1 take away P2 is positive, which means that P1 is bigger than P2? So can you imagine P1 is men and P2 is women, and we're asking them, do they like pickles? If this is my 95% confidence interval of the difference between them, and everybody is positive, that is telling me that men like pickles more than women. if my 95% confidence interval of the difference ends up being, what's that telling me? If this interval is telling me that P1 is greater than P2, men like pickles more than women, what is this interval telling me?
Less than?
And the third situation might be that the 95% confidence interval ends up being that guy. Now, if the interval contains 0, as it does here, isn't that inconclusive? Right? You can't tell if one is bigger or less than the other. Now, these are not hypothesis tests. These are just, this is a reasonable assumption to make based on the interval for the difference or the interval for a single value. Right, Rose, why did the Canadian cross the road?
I don't know.
Because he saw an American do it first. Okay. What's the difference between a Canadian and a canoe?
I don't know.
Canoes can tip.
Okay, that's kind of true though.
Did you hear about the Canadian who get killed ironing his curtains?
No.
He fell out the window. No. Okay. Why can't Canadians make ice cubes? They lost the recipe. Okay, anybody got a couple of
That's pretty good.
Oh, that one you liked. Out of all the list, you liked the ice one. Okay. Anybody got some jokes to just break up the, you know, the seriousness of what's going on right now? Come on. Zach, you must have one of your kids' jokes, surely. Your son.
I got a dad joke.
Uh-huh.
Let's see. How's it go again? Oh, you're American when you're in the bathroom, and you're American when you're out of the bathroom. What are you when you're in the bathroom?
European.
There you go.
Oh. Just because it's in my head. I was over visiting Scotland, visiting my family, and I was, you get jet lagged. At least I get jet lagged every time I go. So your sleeping habits are really weird. So anyway, it was like 2 or 3 in the morning, and I was watching television and on the cable, and something about the British and in general the European television system is a lot more lax, I guess you'd call the word. Anyway, they had this show that was on, and essentially it was so bad it was mesmerizing. What they did is they took to various cities a big truck, and it was a TV booth, and it was Complain, basically. And so you'd go in and you'd sit in front of a little camera and like you little press the record button, and you got 30 seconds or 3 minutes, whatever it was, to complain about whatever you wanted to complain about. And then the show just broadcasted it without any editing. And so you got the usual things of drunks who couldn't put a coherent sentence together, but they wanted to complain about something, and they were hilarious. And then they got this person on, and immediately caught my attention because he was about, well into his 60s, right? And he had a lot of stubble, and he had makeup on, and not very well put on makeup, but nonetheless it was makeup. And I was thinking, I wonder what he's going to complain about. And sure enough, he brings out his bus pass. In Britain, you get a thing when you reach pensioner age, you get a bus pass. Essentially, it allows you to use the public transport system for free. So if you want to take a bus into the city, you just show your bus pass, and you get to travel for free. And he got his bus pass, and he started doing, essentially, I'll call it a rant, about how he couldn't use his bus pass, because his bus pass, he was a guy in a suit. But evidently he didn't always dress as a guy in a suit. He liked to dress in a different one. And he was saying, they wouldn't let me on the bus because I don't look like my picture on the card. And he was going on about, how this was unfair. And I was just thinking, oh God, only in Britain would that be a problem, that you couldn't get on the bus because your picture didn't look like the card. He was annoyed that he had to pay for his fare or something, and I thought that, oh God, I just couldn't take my eyes off it. I was just thinking, what a weird world we live in when people have that as their major problem in life, that they can't get a free bus because they don't look like their picture.
Yeah, first world problems, right?
Yeah, first world problems. We are really annoyed at what that McDonald's ran out of chicken wings or whatever, as if that's a big problem in your life. Anyway, we're getting pretty close, I think, anyway, to the end. My brain's almost fried. I am so looking forward to, as all of you are, tomorrow being over. When it is over tomorrow, I will be spending pretty much all day Friday doing all the things I need to do, right? Grading it, checking it. The WebAssign stuff, I always go over and I will check, because WebAssign's kind of cruel. You could do something 90% right and it still gives you 0 because you did 3 decimal places and not 2, or you picked option 2 and option 3 would have been just as good. So anyway, I'll fix all that and I will send you out one last letter. And the last letter you will get will be your grade. So you'll be able to tell what you got in the final, what your grade is because of that. And then you've got like a couple of days to have one last check for that isn't right or this isn't right. And once that 2-day period is over, I will publish your grade and that will be you. So I want you all to get 4.0s. But if you can't get a 4.0, get a 2.0. And if you can't get a 2.0, get a 0.7, so at least you can tick your math box and get closer to your associate's degree. But your first goal is to get a 4.0.
And that email is going to the student email account, right?
Yeah, it'll go to your student. Now, if you know that that's not a good one because you don't always get it, for instance, Mackenzie won't mind me saying this. I sent it to the new email. Did it arrive the next time? Right. So if you're not getting it, or student email's a bit of a pain or whatever, you need to shoot me an email, and in the email, tell me what the email you want to use. Because if I just click on it, Canvas. Anyway, it's a pain in the butt to get emails if I just click on it. So if you write it down, I just copy and paste, and my life's 10 times simpler.
Is the final going to be the same as like the midterm? So it's like 10 in Canvas and 10 in WebAssign?
That is a really good question. Where are we? Are you looking at the white screen right now?
Yes.
Right, okay, so give me a chance and I'm going to do some.
And are the times the same as the midterm? Like, was it 10 to 1 or something like that?
Yeah.
Yes. Okay, I'm looking up the future because it's already written. And here it is. The final part A, which is the WebAssign questions coming up, are going to be 10 questions. the second half of the test, okay, I have to close about 40 blinking windows to make that happen. And you notice how good I am at not swearing? Did you notice that? Do you know what caused that? My dad swore like a trooper, right? My dad's a coal miner, tough as nails, could swear with the best of them. And my mum, totally opposite, never, I'm sure she did, but I never remember her swearing, ever. And so my personality was after my mum. Second to that, I was brought up by my 6 older sisters who don't swear either. So you can see how the way you live will alter your adulthood very often. Now, that doesn't mean I don't swear, because every normal human being will swear occasionally. But in a way, it's kind of useful, because if you ever hear me swearing, I'm really annoyed, right? Because I'll pick on poor Zach. Zach might swear as part of his everyday conversational language, right? Especially when he's talking to his buddies, right? You're not angry, it's just, you know, a way of emphasizing, right? I don't do that. But if I swear, it's really horrible. Well, I think so. It's not very nice of me, but I do it. Almost there. I have to open up a few more windows to find the damn thing. And I'll be able to tell you. So anyway, the first one is 10 questions. Now remember, they're SALT questions. So aren't SALT questions typically quite quick? You just need to hit in the numbers and read them off and put them in the right place, and you should be good. So don't get overwhelmed by that looking like it's a big number, because it's not really.
Are we for the like regular Canvas ones?
Yes,
Some
that's
of
what I'm
those
looking up right now.
plugged, but can some of those be plugged into SALT to get answers, or no?
No, I've deliberately made it so you don't need SALT for those questions.
Okay.
Right. So, for instance, if you get a mean mode median question, won't you use the calculator for those? So
Yes.
you won't necessarily show me working, but you can do it through a calculator.
Okay.
Right. There are altogether in section 2, 10 multiple choice questions. So A, B, C, D, pick a letter. And finally, 6 questions where you have to actually spend some time doing work. So the 6 longest questions are going to be the section 2 ones. And they will be questions like, you know, the probability ones, box plots, mean mode median, 5-figure summary, things you can do either by hand or using your calculator. And the multiple choice questions, I've picked them because they are, here's a story, one of these 4 answers is the right answer, right? So that's how that's going to work.